In this video, we're going to have a look at how to rationalize the denominator. If we have a look at example 1, you can see that we have a surd on the denominator. When we are asked to rationalize the denominator, what that means is we want to somehow manipulate this fraction in such a way that the surd on the denominator disappears. So, what we're going to do, if we think back to just basic fraction work, 2/6, don't write this down. See, if I multiplied this by 5 and this by 5, I would get what? I'd get 10/30ths. These two fractions look different, but they're exactly the same. Okay, because I've done the same operation to both the numerator and denominator. So these are equivalent fractions. We apply this thinking to surds. What we're going to do is we need to recall from a previous video that when you multiply a surd by itself, you just get the value within the surd. Root 7 times root 7 is 7. So if I want to get rid of that root 5, I'm going to need to multiply it by root 5. But what I do to the denominator, I must also need to do to the numerator. So then we can then proceed. So we're going to do 2 times root 5, which is 2 root 5. And then we've got root 5 times root 5, which is 5. We now have a rational denominator. There is no surd on the denominator. Okay, so that's us finished. Essentially, we multiply the numerator and denominator by the surd on the denominator. Example 2. 4 over root 7. We want to rationalise this. Well, if we want to get rid of that root 7 on the denominator, we're going to need to multiply that by root 7. If I do that to the denominator, I need to do it to the numerator. Multiplying, that's going to give me 4 root 7 over 7. That has now got a rational denominator. There's a real number on the denominator. Example 3. 3 over 2 root 6. One wee thing here to spot is we've got a 2 on the denominator as well, but we just want to get rid of the root 6. So we're going to multiply numerator and denominator by root 6. This one's a little bit harder. 3 times root 6, I'm going to do it underneath, that's 3 root 6. Root 6 times root 6 is 6. But then I also need to multiply that by 2. So I've got 2 times 6, which is 12. And I can simplify this a little bit further, because if I have a look at my whole numbers here, 3 goes into that once, and 3 goes into that 4 times. So I'm going to have 1 root 6 over 4. And we just write that as root 6 over 4. Importantly, there is no surd on the denominator. Yes, there's a surd on the numerator, but when we want to rationalise the denominator, that means to get rid of the surd on the denominator. Example 4. 6 over 4 root 5. Actually, I'm going to change that to, I'll do 26 over 4 root 5. So we don't want to have a surd on the denominator. So we want to get rid of that root 5. So in order to do that, we're going to need to multiply this by root 5 over root 5. 26 times root 5 is 26 root 5. Root 5 times root 5 is 5. And then I need to multiply that by 4. 5 times 4 is 20. And then we can do a wee bit of simplification. 2 goes into that 10 times. 2 goes into that 13 times. So my final answer is going to be 13 root 5 over 10. No surd on the denominator. We've got a rational denominator. 2 examples to go. Root 6 over root 3. This is our first example where we've got a surd on the numerator and the denominator. Right, let's see, what do we have to do here? Well, we don't want to have a surd on the denominator. So I don't want this root 3 to be here. So I need to try and eliminate it. So I'm going to multiply numerator and denominator by root 3. And as long as I do the same to the numerator and denominator, it's still going to be equivalent. So on the numerator, I've got a third multiplied by a third, so I can combine those. That's going to be root 18. Root 3 times root 3, that's just 3. But when you work with thirds, you always need to check, can I simplify them? Is there a square number that goes into root 18? Or is there a square number that goes into 18? Yeah, 9. That's 9 times 2 over 3. That's the square root of 9 times the square root of 2 over 3. Square root of 9 is 3. 3 root 2 over 3. And hopefully you can see 3 goes into this once and into this once. So I'm going to have 1 root 2 over 1. So that's just going to be root 2. So importantly, there is no third on the denominator. Okay, so a lot more work involved there. But the essential step of multiplying thirds comes from multiplying numerator and denominator by the third on the denominator. Final example. 8 root 10 over 3 root 2. I don't want to have this third on the denominator. I'm going to need to multiply numerator and denominator by root 2. That will give us 8 root 20 over, what have we got? Well, we've got root 2 multiplied by root 2. That's 2. I need to multiply that by 3. 2 3s are 6. Let's have a look at our numbers first. Let's simplify our 8 and our 6. 2 goes into that 3 times and into this 4 times. That's going to be 4 root 20 over 3. Okay, let's have a look at root 20. Square numbers that go into 20. Yeah, that's 4, isn't it? 4 square number. So that's going to be 4 lots of root 4, root 5 over 3. Square root of 4 is 2, so I've got 4 lots of 2. That's 8 root 5 over 3. No thirds on the denominator. Okay, so there's a process for rationalising the denominator. 6 examples. You might need to watch this a few times just to get the techniques in place. But hopefully that was helpful and hopefully it was useful. Comes up every year in National 5. Thank you very much.